Hello and welcome to our workbook 8, and we're going to look at this question 4 in 9.3. Now what we're looking at is the alpaca fleece with this, and a bit of background about what's being said here. So in 2013, the average fleece of an alpaca herd was 20.93 microns, and the population standard deviation was known to be 2.89. Now in 2017, a random sample of 80 alpacas gave a sample mean of this. Now we want to test this at the 5% significance level of whether the population mean has changed or not. And these are the steps we need to make. And we'll make this throughout what we're doing here. So firstly, I'm going to highlight what we need to know here. So let's highlight this stuff. This is important. This is important. Now remember, those two are the sample mean and the sample standard deviation. This here is our sample mean here. And this here is the 5% significance level we need to do. And we're going to do the rest now. So the first thing is my null hypothesis, mine's HO. So the hypothesis, that is going to be where mu equals this, because we want to know, has it changed since 2013 or not? So that's 20.3 microns. Now our alternative hypothesis is going to be, because it's two-tailed, remember this is two-tailed, so it's not going to be equal to 20.3. So it has changed. So this would be has changed. This is no change up here at the top. So if we find our answer is greater than this, well, it's changed. If it's less than this, it's changed. Therefore, we just say it does not equal 20.3. Now, we're going to put all this information now into our calculator, and this numWorks will do the whole job for us. So the first thing we do is we go down to inference statistics, press OK. Now, I'm going to go back and I'm going to put in the null hypothesis. And you can see the null hypothesis should be 20.3, and I've got it in here. And you change the alternative hypothesis, so it's not equal to 20.3. Scroll on it and pick which is relevant. Not equal for us. Let's go down to next. Now we input the statistics. So our mean is 19.2. Our standard deviation is 2.89, the second one. The amount of alpacas we have is 80. Put that in. Then we've got our significance level, which is 0.05. That's the significance level, 5% as a decimal, 0.05. Press OK. Then we press next. Now you can see here that our SAID value. Our SAID value here that we have, the SAID score, equals negative 3.4. I'm going to call it 3.40 to 2 decimal places. And our p-value here, that's going to be 6, that equals 6.631 e to the negative 4, it says in our calculator. Now what that means is we need to move decimal place to the left 4 places. 1, 2, 3, 4, 4. So we're going to do that now. I'm going to say, well, let's do that. So 6, 6, 3, 1, put a few zeros in front. And you can see I'm going to move it from here where it is. 1, 2, 3, 4. It gets smaller. So put a point here, 0 here. So I'm going to estimate that to be 0.0007, round this here up to 7. So the next thing I'm going to look at now, since I've got my test done, we did this part, we've done the statistics test. Next is the critical values. Do we reject the region? What's the rejected region? And so forth. So what we're going to look at now is the two-tailed test. And since in our case, since this SAID score, when you make the SAID score positive, that's what these two lines mean, the modulus of this, the absolute value of it, make it positive, that becomes 3.4. And 3.4 is indeed greater than 1.96. This is greater. 3.14, make it positive. 3.4 is greater than 1.96. And because the p-value is smaller than 0.05, which you can see, this here is smaller than 0.05, we are going to reject. We will reject the null hypothesis. So that means there has been a change. It has changed. It's not the same as it was previously. So we have statistical evidence to show that this changes. And that's our conclusion. And you write that down. So you should write at the end, there is statistical significant evidence at the 5% level that the average fleece of herd has changed since 2013. That's it. Thank you very much for watching. Have a good day.